All right, so now we're going to get into one of the most important things about chemical reactions, and that's balancing the chemical equations. If you can't do this properly, then when we get into the next unit where we're dealing with we perform a reaction in the lab. We have X number of grams of one reactant and X number of grams of another reactant. Can we predict how much of the product we should get? Well, the first thing you always do before that, any calculation, is you are going to balance or write out a balanced chemical equation. So let me kind of go over some of the ground rules or some of the most common mistakes that students make in this, and then we're going to jump into this. So, important rule number one, you can only change coefficients, not the formulas. And what do I mean by this? Well, let's say we have an equation that has water in it. And in the product, I need to balance the equation by adding more oxygen. I cannot just say, oh, let me change the subscript to a 2. That'll give me more oxygens. If you do this, you change the identity of the compound. So this is water. This is a compound called hydrogen peroxide. This is why you cannot change the subscripts of the formulas. Okay, so don't ever do that. Secondly, coefficients must be whole numbers. Now, sometimes we may use fractions temporarily, but our final answer will not have any fractions in it. And then lastly, coefficients must be reduced to lowest terms, kind of like a fraction. What do I mean by that? Well, let's say we have a chemical equation that 3A is going to 3B. Well, if I can divide every single aspect of this reaction by the same number and reduce it, then you have to do that. So I can divide both of those things by 3, and my balanced equation will look like this. This is a correct one. This is not. All right, so let's do a quick example of this, kind of go through the process. I'm gonna do a ton of this, so you'll have a lot of opportunity to get this down. All right, so for example, water decomposes to hydrogen gas and oxygen gas. All right, then this is how the problem is basically given to you. And then I'll say, write a balanced equation that describes this process. Okay, well, first thing you want to do is kind of interpret what are my reactants and products. So the water here, I'm starting with water. That's going to be a reactant. Decomposes, like this phrase right here is telling me that's my reaction arrow. And then hydrogen gas is going to be a product. Oxygen gas is going to be a product. All right, so let's start off by putting water, H2O. Hopefully you know the formula for that. And we'll just put it in the liquid phase. I tell you what phases they're going to be in. And then that's going to decompose to hydrogen gas and oxygen gas. We use a little plus sign to separate components. Doesn't mean like it's added together like an addition problem. It's just think of it like an and. So hydrogen and oxygen. Okay, so how do we figure out how to balance this? Well, let's just set up a little chart here of each of our atoms. So I'm gonna do hydrogen, and then I always do like reactants and products on the right, reactants on the left, products on the right. I do the same thing for oxygen here. Here are my reactants, and here are my products. I'm just going to count the atoms. So on the reactant side, I have two hydrogens, and on the product side, I have two hydrogens. Okay, great. Hydrogens are balanced. But for oxygen, I have one oxygen on the right and two on the product side. So this equation is not balanced. Now, let me tell you what you do not do. You don't go over here and say, oh, I'll fix that. There, I got two oxygens on the left side now. I'm good to go. Absolutely not. You've just changed water into hydrogen peroxide. So the way you're going to balance it is with coefficients. Okay, so I'm deficient on the left with oxygens. The way I'm going to get my two oxygens is I'm going to put a 2 there. And that fixes my oxygens. I now have two oxygens on the left and two oxygens on the right. Now, you might be sitting there screaming at your computer screen right now saying, wait, you just screwed up the hydrogens because now I have four hydrogens on the left and two hydrogens on the right. All right, that's okay. A lot of times that happens. So how do we fix the hydrogens on the product side? Well, I already got two. I can add another two by doing that. Because what that is saying now is that instead of one hydrogen molecule, I now have two. So how many hydrogens is that? Now that is four on the left, four on the right. So my hydrogens are balanced, my oxygens are balanced. I'm going to do one final check. So I'm going to count. On the left, I have four hydrogens. The way you kind of do this is you take your coefficient and multiply each subscript by that coefficient. So that tells me I have four hydrogens, two oxygens. And then on the right side, I have four hydrogens, multiply that there. I have one thing of O2, so that's two oxygens. I have a balanced equation, and that is my final answer. So let's talk a little bit about some more complex things. So I'm going to give you a couple, few pro tips to go through here. One of the things that you'll use quite often as a lot of students ask, well, where do I start? Start with atoms that are found only in one compound on each side. So let's use this as an example. We have butane, and I'll give you the formula there, is combusted in oxygen to form carbon dioxide gas and water vapor. So let's identify our reactants, butane and oxygen. And here's that kind of phrase that tells us where our reaction arrow is. To form carbon dioxide, CO2, and water vapor, H2O. Those are our products. So let's put all this down. C4H10 and O2. We're going to heat it up to produce carbon dioxide gas and H2O. Now, a couple of things I want you to notice. Notice that oxygen is found in two places on the product side. So what does that mean? Don't try to balance oxygen first. Carbon and hydrogen are only found once on each side. So when I try to balance this, I'm going to start with either carbon or hydrogen. Those are the ones I'm going to fix first, and then I'll save oxygen for the end. So let's draw out our little tables here. Carbon, hydrogen, oxygen. All right, how many carbons do I have on the left? I got 4 on the left and 1 on the right. Hydrogens, I have 10 on the left and 2 on the right. And then oxygens, I have 2 on the left and 3 on the right. So again, now I'm going to start with either carbon or hydrogen. I'll just start with carbon here. Okay, so I have 4 carbons on the left. I can easily fix that on the right by putting a coefficient of 4 there. That would give me 4 carbons. So 4 and 4 now. All right, now let's fix the hydrogens. So I have 10 on the left and I have 2 on the right. How can I fix the hydrogens? Well, since each water molecule supplies 2 hydrogens, if I were to have 5 water molecules, that's a total of 10 hydrogens. So now I have 10 and 10. All right, now you might be thinking this whole time, I'm completely throwing off the number of oxygens. And that's fine. That's why we save it to the end, because I still have 2 on the left. And now how many do I have on the right? Well, I got 8 from CO2 and 5 from water. That's 13. Okay. Now that we've taken care of everything else, we can take care of the oxygen, and I'm going to focus on balancing that. Now you might be looking at this and say, how do I balance that? I need to, like, if I put 13 there, that's going to give me like 26 oxygens. Or if I put, I need 11 more. If I put 11 there, that's going to give me 22 oxygens. Like, how do I balance the oxygens here? All right, well, here's kind of, another pro tip. You can temporarily use fractions. I'll tell you how we're going to get rid of it in a minute. But I want you to think about this for a second. If you have 13 over 2, and then you multiply that by 2, what does that make? That makes 13. So now I technically have 13 oxygens on the left and 13 oxygens on the right. Now, this is not my final answer. I'm not going to leave it like this because, as I said on the previous page, like one of the ground rules is we can't have fractions. So what I'm going to do is multiply every single coefficient. So we can't have fractions. I'm going to multiply every coefficient by 2. I'm just going to kind of like do this times 2. And I'm going to rewrite this down here. So now I have 2C4H10 plus 13O2 and that's going to make 8CO2 plus 10H2O. Notice I only multiplied the coefficients. I did nothing with the subscripts and the molecules. I can only mess with the coefficients. And now let's double check our answer. I got 8 carbons on the left, 8 carbons on the right. I have 20 hydrogens on the left and 20 hydrogens on the right. And then I have 26 oxygens on the left And then let's see, 16 from carbon dioxide, 10 from water. That's 26 oxygens on the right. So that is my balanced equation. And notice that it is in its lowest terms. Everything's got a coefficient, and that's fine, but I can't divide any by a certain number and get a whole number. So it's reduced, quote unquote, to its lowest terms.